In this video, I'm going to go through the first part of exercise 9.15. And in this exercise, they say that, well, lemma 8.2 4.5 showed admissibility of this substitution rule. So if you have A, then we have A with T substituted for X if T is substitutable for X in A. And now they're asking us to show that this rule is sound. So basically, for any gamma and first order logic structure M that satisfies gamma, if M satisfies A, then also M satisfies A with T substituted for X, of course, when the substitution is legal. So what we're going to do here is going to do a good old-fashioned proof by contradiction. So we're going to assume this, and we're going to assume the negation of this, so that M doesn't satisfy A with T substituted for X. And then we're going to reach a contradiction and say, hey, well, that means that M must satisfy this. Okay, so here we're going to start by saying that M satisfies A. And by fact, this is our assumption. So by fact 9.27, we've used this before, but I'm going to bring it up again. So fact 9.27 just says that if M satisfies if M satisfies A, then we have, this is equivalent to M satisfying for all A. Specifically, this also means that M satisfies for all XA. So now we want to show that M satisfies this with the substitution, and then we do the contradiction where we just assume that it doesn't satisfy the substitution. And then this, if M doesn't satisfy this A with substitution, this means that there is some valuation, some assignment here, such that this is valuated to 0. So if M satisfies A XC, it means there is no valuation that evaluates to 0, all valuations evaluated to 1. So we're going to use this assumption here, that there is a valuation which makes it equal to 0, and then we're going to bring out some kind of a contradiction. And I can give a hint here if you want to attempt to do the exercise before I go through the answer. This contradiction which you're going to derive, it's essentially, it contradicts with that M satisfies A. So you're going to reach some kind of form of that M doesn't satisfy A. I want you to think about this at the same time. And you're also going to be using, let's see, you're going to be using exercise 9.10. Sorry, 9.10.1. And you haven't done exercise 9.10.1 yet. I recommend that you do. It's very helpful. It's not that complicated, but I'm not going to go through the proof for this now. I'm just going to use the result. Just know that I'm going to use the result from 9.10.1 in the proof. So you can use this and the hint that I gave before to maybe attempt to make this proof. And then I'm going to continue in a second if you want to just see me do the solution. Okay, hopefully you attempted to finish the proof with these hints. So what we're going to do is we have assumed that this equals 0 here. So this was the assumption, that there is some valuation V's which values it to 0. And then we're going to use lemma 9.7. So lemma 9.7, let me bring it up here. Lemma 9.7 just tells us that every free variable in A, for every free variable in A, valuation V which maps A and valuation W which maps A, if they're the same for every, sorry, not A, for every X, where X is a free variable in A, if they're the same, then A under MV is the same as A under MW, because all the free variables are mapped to the same thing under these valuations. So these valuations are essentially identical with respect to A. So we've done this. We're going to use we'll use lemma 9.7 because this v and this v are the same here, because remember, y is a fresh variable. It doesn't occur in a or in a with t substituted by x, so this doesn't really have an effect. Hence, this v and this v are the same. These are the same. Hence, this here also equals 0. Okay, so we're going to use lemma 9.7 again and look at these variables here. So we have that y under m and v, which maps y to a, just equals a, because we're mapping y to a. So this just equals a. But then up here we said that a was t under m and v. So we're under m and v right now. So this just equals t here. And then by using lemma 9.7 again, we say that, well, this just means that we have that this is equal to t under mv with this little extension here. Okay, so now we're going to use a new lemma, which I haven't used before. It's lemma 9.9. I can bring it up here. Lemma 9.9 just says that if t1 and t2 are both substitutable for x in a, then t1 under m and v equals t2 under m and v, so they're the same under this structure and valuation. Then a with t1 substituted for x under m and v is the same as a with t2 substituted for x under a and v, because here t1 and t2 are they're the same thing under m and v. So this makes sense. We're going to use this lemma here, and we know that t and y are both substitutable for x and a, and therefore we have that this here can be set equal to this over here. So now we know that this is evaluated to 0. I'm going to pause here again, because if you got stuck the last time in your attempt, I can tell you now that now is when you maybe want to use the result from exercise 9.10.1. So I'm just going to pause here for a second, and you can try to finish the proof, because there's not much left. Okay, so the last part of the proof, so if this equals 0, then it implies that the negation of this, so the negation of a with y substituted for x, equals 1. And so by, I'm going to actually write that this is by definition 9.4. So we're using definition 9.4 to say that therefore we have existence y negation a xy under m and v equals 1. Okay, so since y was fresh and does not occur in a, remember we said that y was fresh up here, then we can use exercise 9.10.1 here, which told us that if we have existence y a y x, then we just have ex a. So now we have ex negation a under m and v equal to 1. And this actually just means, so if you have the existent x such that negation of a, it means that not every x is in a, essentially. So these are the same. And if the negation of this equals 1, then the non-negation equals 0. But now we've reached the contradiction, because we had at the top, remember, by fact 9.27, that m satisfied for all xa, which means that there is no valuation which can evaluate this to 0. This is a contradiction. And since we've reached that contradiction, it must be so that m satisfies a with the t substituted for x.